All right, hey guys, my name is Maya Bailey, and today I'm going to be talking to you guys about the mystery of dark matter. So, to start off, we got to talk about essentially what dark matter is. In dark matter, we're actually certain of what it isn't more of than what it is. So, dark matter, we know that dark matter does not consist of any dark clouds and it's not made up of barons. We know that it's an invisible matter that does not contain or emit any light. Dark matter is not an antimatter because there is no gamma rays present when an antimatter destroys matter. The main element of dark matter is that it is dark, yet scientists are still unable to conclude what dark matter consists of. Dark matter does not emit any light and therefore it is not visible. It has no X rays or no infrared waves. Dark matter is invisible and does not emit any light, and due to the fact that it does not emit any light or energy, it makes it very hard to detect in our galaxy. So now that we know what dark matter is, the question is, how do we know it exists? And the answer to how it exists is through gravity. The force of gravity can affect the bending of light, but it also is responsible for the orbits of stars. The theory is proved through gravitational lensing, and this is done by studying how light distorts throughout the galaxy clusters. And by doing this, astronomers have been able to identify dark matter throughout the universe. There was a study conducted in the 1930s that measured the motion of group galaxies while weighing the amount of matter they contained, and they discovered that there is not enough visible matter that could hold those stars and galaxies together. They came to the conclusion that there is not enough visible matter to provide gravity to hold those galaxies together. So, with that being said, these galaxies should just fall apart, but they don't. So, therefore, there must be some sort of matter there that we can't see that's holding those galaxies together. And that's essentially where the whole idea of dark matter comes from. Through studies and actually fun facts, dark energy makes up 68% of our universe, and dark matter only makes up 27% of our universe. And that leaves us the measly little 5% of the matter that we can see. Now, I don't know about you guys, that actually makes me feel pretty small in the world. But by studying how light distorts itself in galaxy clusters, astronomers are able to determine the ample amount of dark matter in the universe. Dark matter is distributed across the cosmos in a net wave pattern, so to say. So now we're going to talk about the different theories of dark matter. And there's mainly three, but the first one we're going to start off with is the weirdest name I have ever heard of. It's called MACHOS. So, MACHOS are objects ranging from small to large black holes. They're made up of ordinary matter such as protons, neutrons, and electrons. Neutron stars and black holes are 3 times the mass of the sun. They're both a result of the supernova, a huge star, and therefore they discard cloud gas remnants. The theory is that the objects must travel far from the remnant to be hidden. The reason why we consider MACHOS to be a theory of dark matter is because the neutron stars is very big when isolated, and that can appear as dark. The only problem with this inference is that because the neutron stars come from the supernova, they are not considered common objects. There should be a massive amount of energy there, but there's no evidence to support this. Then the next one is called brown dwarfs. Now, brown dwarfs have a mass twice as small as the mass of the sun, and this results in no nuclear reactions occurring, and therefore there is no shine like the one we see in stars. Einstein discovered that the gravitational attraction of massive objects can bend the path of light rays, much like a lens does. Therefore, when a large object passes in front of a small object, like a star or a galaxy, the light becomes focused from the small object, and this allows for the object to appear bright for a slight amount of time. Brown dwarfs are usually searched for in our galaxy by monitoring the brightness of stars while in or near the center of the galaxy of stars in a large magellanic cloud. And they use gravitational lens to observe this for about 6 years of research. The pros is that we have found brown dwarfs in our universe, but the downside to this is that there's not enough evidence to prove that this is what accounts for dark matter. The last one we're going to talk about is called WIMPs, and I know it's a really weird name, but it stands for weakly interacting massive particles. And WIMPs consist of subatomic particles, which are non-ordinary matter, and these particles can pass through ordinary matter without even affecting it. They can consist of neutrinos, axions, and neutralinos, so we're going to touch on all three of them. So, neutrinos were first discovered by physicists in the 20th century, And in 1998, they found out that neutrinos did have a mass, but unfortunately, that mass was too small to be considered a factor of dark matter. Then there's the axions, and the axions are particles which are inferred to be the reason behind the missing electrical dipole for a neutron. Axions do not have a large mass, but astronomers have inferred that they were produced during the Big Bang theory. The investigation, although, is still ongoing because as we're still searching for axons in the halo of our galaxy and the sun as well, this proves that there's still no evidence. Then there's neutralinos. Neutralinos are another particle which are a part of the theory called supersymmetry, and this theory aligns all the forces of physics. Now, neutralinos are huge particles that may contain a mass of about three of about 30 to 5,000 times the size of a proton, but however, they are lighter in the electrical neutral supersymmetric particles. However, this theory is still ongoing as there has been no actual discovery of these particles yet either. So in conclusion, we're still more certain of what dark matter isn't rather than what it is. But what one thing we are certain of is that it still does exist, because without dark matter, our galaxy would explode, or not necessarily explode, but would expand apart. Well, I hope you guys learned something from my presentation, and I hope one day we can get to the conclusion of what dark matter is. But for now, let's continue to speculate and let's continue to find new theories, and let's hope that one of those theories will lead us one step closer to the mystery of what is dark matter. These are my sources, and thank you for listening.